Saxon's Trig, Lesson 99, is about sequence notation, advanced sequence problems, and the arithmetic and geometric means. And some of this should sound very familiar. So sequence notation is taking the a sub 1 plus, for arithmetic, a sub 1 plus the n minus 1 times the common difference, and we've usually said that that was a sub n. So what they're doing when they change it to a sequence notation is they're saying drop the 1 and just keep the a plus, and it's still the n minus 1 times the difference. And then instead of a sub n, they're changing it to, and I don't know why they feel the need to change the a, but whatever, t sub n or l sub n, whatever sub n, because they've dropped the a sub 1. They don't want it with the a. I guess they feel like that would be a little more confusing. But anyway, that's the notation. Same thing occurs with geometric. So for geometric, we had a sub n equaled a sub 1 multiplying with the common ratio, and the exponent was the n minus 1. So again, they want to drop the a sub 1 and just keep it a to the r, and then change to t sub n or l sub n is what they give you on the bottom of 565. Part B goes into advanced sequence problems. So in example 1, it asks to find the 10th term in a geometric progression, and progression or series, same wording. So find the 10th term. So again, I'm probably going to forget because I'm still so used to calling this a sub 1 and a sub n, but you're looking for the 10th one, t and whatever, who's in the geometric progression that begins with, so over here they're giving me a list, x radical 2, x squared, 2x cubed, and so on. So my first a sub 1, I do know it's x. Oh, just a second. I need to read carefully. I made an assumption it was arithmetic. It says geometric, so let's fix that. It's our a sub 1, and I was about to do the plus, but it's not. So the common ratio, which I don't know, and then 10 minus 1 makes the exponent 9. Okay, now, how do I find the common ratio when they didn't tell it to me? They just gave me the list. Take the second one and divide it by the first one, or take the third one and divide it by the second one. As long as they're sitting side by side, you will be fine. Now, they did it both ways to show. It's like, why am I seeing both? They tried to prove to you that it does give you the same answer no matter which way you do it. You can look at their work for both of those, but I'm going to take the second one, which is the root 2x squared, and I'm going to divide it by the first one, which is x. So this x will cancel off one of these x's, and so my common ratio is root 2x, which I can then plug into here and then manipulate that. So we're looking for the answer for the 10th term, and let's see, I have root 2 9 times. So every set of 2 makes a 2. So I'm just going to write my x for the moment. So then 2 of them makes a 2. 2 more makes another 2. 2, 4, 6, 8. And the extra one is still staying left there. And then this x also got the 9th power. So now x to the 9 and x to the 1 implied, multiply bases, add exponents, that's x to the 10th. 2 times 2 is 4, times 2 is 8, times 2 is 16. The numbers should be in front. So 16x to the 10th. Oh, you know what? I'm going to rewrite that fully. 16 root 2x to the 10th to put it all in the correct order. Now, they chose to write that, oh yeah, not in that format. They chose to write it as a base 2 to the 9/2 x to the 10th. All right, I'm going to write it, and then I'm going to explain what they did. So this 16 was actually 1, 2, 3, 4 exponents, so 2 to the 4th power. This was 2 to the 1/2, So you were adding that with another 1/2, and if you make that improper, that's, well, 4.5, and so then make that 2 times 4 is 8 plus 1 is 9 over 2. So that's how they got it to this format. Either one of these answers is perfectly acceptable because it's the correct simplification of what they wanted the 10th term. Example 2. Find the 4th term in a geometric progression that begins with 2 plus root 6 is the first one, 6 plus 2 root 6 is the second one, and 12 plus 6 root 6 is the third one, and then it says the pattern continues on. All right, so geometric, it wants the 4th one. So we're going to begin with our first one, which is 2 plus root 6, multiplying with, and that's 1 unit, so I'm going to put it in a parenthesis, the common ratio, which I don't know, to the 4 minus 1 cubed. Now, to find the common ratio, you know what, this time let me do it the other way. The third one divided by the second one. So 12 plus 6 root 6 divided by 6 plus 2 root 6. Now the problem with dividing the further up ones that you go, obviously the larger the numbers that you're dealing with, so the easiest is almost always the second divided by the first. All right, but what do I see that I can reduce all of these outside numbers by? 2. So this one goes by 2, this drops to a 3, this drops to a 3, this drops to a 4. Now, 4 plus 3 root 6, okay, I need to fix that because I have a root 6 in the bottom. So what do I multiply the top and the bottom by that eliminates the root? Change the sign in the middle. This goes way back to the beginning. So hopefully you're remembering that rule. And then we have to distribute out. So 4 times 3 is 12 minus 4 root 6, that's those two. And then 3 with the 3 is 9 root 6, and 3 with the negative is negative 3, and root 6 makes a 6, which we'll fix. Then in the bottom, 3 times 3 is 9. Middle terms, I don't even bother to write because it's 1 positive, 1 negative, minus, and then root 6 times root 6 is a 6. Okay, let's do some simplify here. So 3 times 6 is 18. 12 minus 18, negative 6. And these are like terms, so negative 4 plus 9 is 5 root 6 all over, and then 9 minus 6 is 3. So that should be my common ratio, except they're telling me they're getting root 6. Did I make a mistake somewhere? Yeah, I found my error. It was here when I did this reducing by 2. This was a 12 and I wrote a 4. I had 3 on the brain. So 12 divided by 2 should, I'm saying that backwards. No, 12 divided by 2 should be 6. So now let's see where that changes things. So this would have been a 6, not a 4. When I distributed 6 times 3, I should have had 24. 6 here would have been minus 6. Those should not have had a problem. All right, so 24 minus 18 should have been the 6, positive 6. I don't like that I'm still getting a thing there. And then negative 6 plus 9 should have been 3. Oh, well, there, okay. Now we're getting there, I believe. No, because I'm still getting a 2, and I don't want a 2. I want a root 6. Help us all. 6 times 3, not 24. 6 times 3, 18. 18 minus 18, all gone. I knew it should work. Sorry about all the confusion there. Then 3 divided by 3 will be the root 6. Now I've gotten the ratio that I was supposed to get. My goodness. And then we need to fill in and finish it. So this to the 3rd power, I'm going to leave this, and then that's going to make a 6, root 6 left over because root 6 times root 6 makes a 6, and then the other root 6. then distribute. So 2 times 6 is 12 root 6. And then the 6 on the outside, root 6 and root 6 makes another 6. So 12 root 6 plus 36 should be the fourth one in that list. 36, yeah, they just wrote the order differently. Same thing. Oh, that was hard fought. All right, example 3. A ball is dropped from a height of 81 inches. On each bounce, the ball rebounds 2/5 of the distance it fell. How far does it fall on its 6th fall? So the first fall is 81. The common ratio, I don't have to stop and find it. It told me it was 2/5. And since we want 6 minus 1, we want that to the 5th power. So then I might be able to do that in my head, but those numbers are going to get pretty big. So you basically want to take 2 to the 5th power times 81 and divide that by 5 to the 5th power. Or on your calculator, do 2 divided by 5, take that to the 5th power, multiply by 81. However you do it, you should be getting 0.82944, and this was in inches to talk about how much it fell on the 6th fall. All right, part C, arithmetic and geometric means. Now, you already know how to find these, but they're working toward getting you to memorize 2 formulas, one of which you've been doing since elementary school. So in example 4, find the arithmetic mean between x and y. So when it's saying one mean, it's wanting one blank. So you're basically figuring out the formula for mean, which means average. Okay, so let's call this one a sub 1, and this one is 1 to third power, or third term, sorry. And so its formula is coming from a sub 1, and this was arithmetic, so plus, and it's the third one, so 3 minus 1 is 2 times the common difference. So let's put all this together. Y equals x plus 2 differences. To find the difference, then we want to minus the x, y minus x equals 2d, and divide by 2 on both sides to get what the difference is. So y minus x over 2 is the difference, and to get to the middle piece, I would be adding that to the original x, and that needs a common denominator of 2 over 2. So there's nothing I can do with the y, it's still there, but -1 plus 2, and that's implied -1, plus 2 is 1x, so y plus x all over 2 is the middle term or the mean. Now, when we say average something together, what have you been told? Add the 2 numbers and divide by however many that was, which is 2 numbers. So you see that you already know this one instinctively. In example 5, it wants you to find the geometric mean between x and y. Again, one blank, but now we're following the geometric formula. So we know that this is going to be y equals the x multiplied with the common ratio, and the exponent of 3 minus 1 is 2. Again, we want to solve for the r, so we're going to divide by the x, y over x equals r squared, and to get r alone, you're going to square root both sides. So that leaves you r equals, and then when you put a square root around something, remember you've got to plus and minus, and then the square root of y over x is the common ratio. So if you're trying to get to this next term, you're taking this ratio and you're multiplying it times the x to get to the middle piece, and that is going to give you positive and negative. I'm trying to think of the best way or the quickest way to explain this. There's nothing you can do with the root y, so it's going to be stuck there. This x was in the denominator, which technically makes it x to the negative, and it's in a root, so 1/2. And it's multiplying with an x to the 1 common denominator. I'm going to turn that into 2 over 2. When multiplying bases, I'm adding exponents, so -1/2 plus a whole leaves me with 1/2, so x to the 1/2. How do you write x to the 1/2 back into the root format? Well, it's just an x inside that square root as well. So this is the formula for the geometric middle mean, or average, and I would just memorize that as both positive and negative square root of x times y, and that's what they're wanting you to do. Now, in example 6, it says to solve for the positive, and it has to clarify because it can have both a plus and a minus in front, as we just learned, but it wants the positive answer of the geometric mean of two numbers is 8. So our formula is going to say the positive square root of x times y is 8. And the difference between those numbers, x minus y, is 30. Find the two numbers. So I will substitute in, oh, so many ways to start. Yeah, I'm going to solve for x here. So x equals 30 plus y, and then I'm going to substitute that in over here. But before I substitute that, I want to get rid of the square root because I don't want to solve for inside a square root. So that means squaring both sides of this equation. So I get xy equals 64. Now I'm going to plug this in and get my 30 plus y times y equals 64. And distribute 30y plus y squared. And because I see a y squared and a y, I'm thinking factor, so let's go ahead and minus 64 and set it equal to 0. The order is wrong here, but I think I can still factor. So the y squared goes to y and y. This is my middle term. I'm trying to make a 30 out of factoring something with a 64. Now, can I do that? 64, oh, I can't think of any numbers that multiply to give me 64 that might total to be 30. So I can't factor it. If I can't factor it, I've got a quadratic formula it, which is, all right, so let's go ahead and clarify. A is 1, B is the 30, and C is the negative 64. Okay, so then our formula for quadratic, negative B, negative 30, plus or minus the square root of b squared, 30 squared, 900, minus 4 times a times c, all over 2 times a, which is 2. All right, so now 4 times 64, easier on your calculator. 256. Two negatives make a positive, so positive 256 plus 9, that's 1156. Positive and negative square root of 1156. Negative 30 still out here. 2 is still underneath. Can I... Oh, they just jumped to the answers. The square root of 1156 must be a clear-cut number. I'm going to have to backdoor this to get there without my calculator. Okay, got it. 34. So now negative 30 plus 34 should leave me with negative 4 over 2, which is negative 2. And then negative 30 minus 34 would be negative 64 over 2, which would be, no, just a second, is that negative? $32. I have the number, but the sign is backwards. Negative 64 over 2. Positive 1, negative plus that. Oh goodness. Yes, negative 30. So do I have this negative backwards? My answers are right, except the signs are backwards. Because according to me, this should have been positive 4, positive 2. Okay, I just caught what I did here. I solved for the x here, and then when I plugged it in, I put it in. No, that is right, that is for the x. But what I'm yes. What I'm solving for isn't the x's, it's the y's, because that's what I have here in my equation. So these are my y equals numbers. That is okay. It doesn't matter which order I solve it in, but I just need to make sure I have the correct letter. So for one of the y answers, I will have positive 2. For the other y answer, I will have negative 32. And I still need to go back in and get the x answers. So when I plug in the 2, 30 plus 2 makes this match 32. And then when I plug in negative 32, 30 minus 32 is negative 2. And that does match what the answers are that they have. Negative 2 with negative 32, 32 with 2. So just make sure that you were very careful with whatever letter you're solving for, because it will definitely affect the spot in which the answer goes.